welcome to Tremco Live, where we're socially distant but technically connected. I am Marcy Tyler, the Director of Building Science for Tremco, and I'm very happy to be joined by my co-host.
Yes, I was gone for a week or so, but I'm Paul Hugenboom. I'm the president of Tremco Construction Products Group, a tremendous collection of brands, companies, product systems, and of course, most full people all over the world, Marcy.
People all over the world. Paul, a special surprise for you in a couple weeks here. We're going to feature a lot of these people all around the world as one of our segments, so that'll be fun.
Very exciting.
So, Paul, you missed us last week, but I know you always try to stay in touch. We talked about some field testing last week.
Yeah.
So this whole month, we're trying to focus on just that. So performance testing and what that means. Depending on the system, depending on the application, a lot of times you can't get back to these systems to maintain them. So it's pretty critical that we make sure we get it right and we do as much testing as we can up front.
Yeah, and the thing I really like about Tremco is we are just testing fanatics. We're always, it's not just current testing, but we're always working on next generation, what hasn't been tested, right? Yep. And of course, we get the chance to test in controlled conditions. I think Mark's going to talk to us about field testing, which is a lot more exciting, right? It's a lot harder.
It is exciting, yeah. So we talked a lot in the beginning about some of that testing that we can do ahead of time, stuff we do as a manufacturer and as that collaborative partner on the project, but it is important to not go out into the field and verify that installation, or from a restoration perspective, you know, go back and try to see what that issue was, so then we can figure out a solution.
And as you noted, and it's important to be so mindful that so much of the system you can't see or get to once it's constructed.
Yeah.
Easy to forget.
Yeah, I think our guest is going to talk to us a little bit about that too. You know, where the perceived issue might not even be anywhere near that.
Yeah, I think some years ago you educated me, just stack pressures alone can have water migrate in ways that are just completely you would never guess unless you actually pulled the facade off the wall and looked at it.
I think that'd be an interesting thing, like follow the leak would be another cool segment, you know, to kind of shows some of this investigative work that like people like our guest today experience on a regular basis. So really excited as always to have all of you wind down your week with us, and of course the ability to represent so many people. We definitely appreciate that capability. We are really excited to bring our guest on today. So I'm going to go ahead and welcome Mark to Tremco Live, our returning guest to Tremco Live.
Hey everybody.
How you doing today?
I'm doing great. It's Friday.
Good. Cool.
We're not to do any leak testing over the weekend. No leak testing over the weekend.
No leak testing. No leak testing. Unless it's your beer cooler, right?
Exactly.
Yeah. That one might be a cool challenge. So you can make the best beer cooler with the materials on site, right? So
we have Drive It now, so we can build it, right? So.
And Nudura, right? We could do some really cool things with the Nudura products as well. So I was going to trick you a while ago when you and I were having a conversation. You came onto the Microsoft Teams, and your background was your face. Do you remember that? It was your face and then your face. And so I have a really funny picture, so you should be happy I didn't share it today.
Oh,
It's scary. My daughter was sitting near me. She's like, "Who was that?" I'm like, I took it because it looks scary. So anyway, Mark, thanks for joining us again. We're really excited to be able to work with you in so many different ways, and of course to have you as our guest contributor today. Today specifically, we are going to be talking about testing, but I thought it'd be interesting to start off with this information that you shared with me and that whole process that you go through and when you're evaluating a fenestration. So you want to touch on this a little bit for us?
Yeah, this is great. This is really what we try to communicate with everybody we're working with. And I think what's interesting, let's send an email out to some friends of ours over at Panoni, another good engineering firm that we're helping out with something, some leaks that they have. And I think it was really cool because once I finished the email, I looked through what you had in this program. It really is just ingrained, I think, in all of us now and how we even communicate. They have a building that has EIFS on it, It has a storefront punch windows in it. And they got the phone call that it's a medical building. It's about 4 stories tall. So we've talked to all you guys already about what we think about putting stick frame storefront windows on the 2nd, 3rd, and 4th floor. Never a great idea. And it was a very interesting email that kind of underscored what we're going to have here, which is the comment from the client to our friends at this engineering company was, the EIFS leaks. Really? You know that for a fact? You know, and you look at a building like that right out of the gate, you're like, most likely it's probably not going to be that when I start to see windows of those styles on the upper floor. So it's so important that you really don't take a curb shot, right? And a curb shot is standing at the curb looking at saying, it's these. Our industry and these buildings that we work on every day are so unpredictable that an early diagnosis can put you in the grave, man. You really do have to follow a process. It's so important because you don't want to begin to blame or identify other things that really have nothing to do with the water infiltration that's coming in. So the investigation part that we have here, what's so important is that you really take these initial steps to really identify what are we looking at, what's the real problem, really assess the existing condition of it. This particular circumstance, you know, the next step for us in this particular building was, that's great, that's what you think it is. All right, let's step back now and really look at what we have going on. And the investigation portion is when you really begin to ask those questions, right? How long has it been leaking? What direction does the wind come? Does it happen in a certain time of the year when the mechanical system kicks on? There's all these questions in the investigation that you really do have to begin to mine for and ask for. And if there's a lack of institutional memory, that winds up making this investigation step much more challenging, because then you're kind of flying blind a little bit, if that makes sense. You don't really have a lot of good intel to start off with. And you also have to understand the client's goals in this. You know, some clients may really just want a Band-Aid approach to it. Some clients don't really know they even have a problem in the first place. They just know that, you know, John down the hallway has water that drips onto his computer every couple months, and you know, that's pretty much all they know. Sometimes that's all we get. But the investigation starts, I think that's when we really get out there and really look at how do we now replicate these issues that we're having. So that investigation kind of kicks off the testing component like we're talking about. You have to get out there, you have to try and recreate those leaks, really track down that leak path. The investigation really begins to start this process, where you then go right into design, bidding, construction administration, and then you get into testing again at the back end into quality assurance. So testing is really at the forefront and at the back end of any project. We just, Jimmy and I just sat down and reviewed a project where we're doing EIFS repairs, and this is some crazy rooftop unit that sticks into a building, and they never transitioned from the rooftop unit to the EIFS. And we just went through this process where we did the investigation, we did the testing, we made it leak, we know the leak path, and I'll be darned, what are we doing now when we're designing the project and putting together the project manual? We're putting together a quality assurance plan that includes testing. And we're testing to try and make sure that whatever we said we're fixing, we're fixing. So it's just important to kind of cycle through these things, and testing really does sit that's the forefront of investigation, and it's really important at the end of the day that you end that kind of a system with quality assurance.
And I love it because you talk about the testing in the beginning and at the end, right? So you need to test it because you're trying to identify why, right? And sometimes it makes people uncomfortable. You want to see where the leak's happening, right? So you want to induce it, and then obviously you want to verify your installed fix at the end. So
yeah, I say a lot of times I tell people, look, if I can't make it leak, I can't tell you what's happening. I really do have to make it leak to really get a good handle on what we're having. Paul mentioned, you know, running leaks. That's what we call them, which means it's getting in here and it's actually dripping all the way over there. So that's a problem. You know, you really have to take your time and go through the testing, and the anxiety, I think, is interesting. I don't know if other people on the line actually do this testing, but there's a lot of anxiety when you're doing this testing to actually make it leak. And sometimes, you know, you're looking at your watch and you're like, oh boy, am I going down a rabbit hole? But welcome to leak testing. This is how it goes. You do your best shot. You understand the basis of the design the best you can, but you know, that it is what it is at the end of the day, and you might have to go on to another location to test, you know?
Well, it's interesting. So I was telling Paul that I had a leak in my house. So I was having issue in one of my bathrooms, and when the guy came over, he's like, "Well, I'm going to turn the water on because I want to force it to leak again, and I want to follow the leak." And I'm like, "Okay." And I think he was like, "Why is she okay? What? I just told her I'm going to cause more damage in her house so I can see where this leak's coming from." And I was like, "Okay." I think if he wouldn't have done that, I would have been mad. I'd be like, "You can't just go in and rip the toilet off. You got to figure out where it's coming from." I'm sorry.
Yeah, our own little lives, right? I had a call yesterday with my friends from Pullman, and my buddy Dennis told me that he still hasn't fixed his leaking chimney in like 10 years. And here, it's what we do for a living, right? Sometimes this stuff is crazy.
I know, it's interesting for sure. I know this next slide here has a building on it that we all probably recognize very well, but this goes back through just some of the comments that you said and kind of takes it to a deeper level here. And of course, that's our University Tower project that we worked on with you.
Yeah, that was a fun project for all of us. It was a good team effort. Yeah, the old Pickle building, right? That's the architect's last name, and that's kind of what's called down there in the Carolinas is the Pickle building.
I didn't know that. It's interesting.
Yeah. Matter of fact, it's interesting. I believe the owner, who was the developer who originally developed it, his son was a lacrosse player down at Duke, and he used to visit the site, and that's why and they were actually from Texas. So if you look at this building, man, it looks like a Texas building, honestly. This kind of has that style, right? And here he's from Texas. His kid went to Duke, and he wound up buying this property and building the Pickle building with the architect Pickle. So interesting background, but. Well, when he built it, it leaked. So as interesting it may be, our zipper gasket system definitely had some age to it. This was a cool project because we did have a good friend of ours, Mike Coopers, from High Rise, was, caulking the dickens out of this building for years. Just kind of get a leak, drop down, caulk it. Get a leak, drop down, caulk it. Wind came from this side, caulk this side. Wind came from this side, caulk this side. So it was always very reactive. Sometimes he won, sometimes he lost. At the same time, Mike, who's part of the Sealant Waterproofing Restorations, began to chirp to the property management company, "You know what I'm doing? I'm just chasing things around. If you really want to fix this, let's stop chasing it and start to really understand why it's happening and go through a process." And Mike's a smart contractor that was really, I think, patient with this client and really explained to them the benefits of it. And it took a little bit of time to get them comfortable with getting a consultant involved. But when we started with Mike, they had, I believe, it was over 50 reoccurring leaks around the building. And they were based on what direction the wind may come. And when we talk about testing, this is when, if I had hair, you start pulling on it, right? Because you're like, okay, so where do we start? Like, if the wind comes from the north, it leaks. So what are we testing? Also, what Paul mentioned is incredibly important on a building like this. Just spraying water on isn't enough when you do testing on this, right? You got to create some pressurization. It's a big building, right? So when we first got involved out here, it was really, how do we go through a basis of understanding and recreating leaks? And I think that assessment of the zipper gasket system and the basis of design, right? We always talk about that. The most important thing is identify how this thing was supposed to work in the first place. And it took a little bit of time to get our arms around it. There were some other actually really good consultants that we're friends with that published some really good articles on zipper gasket systems. So we're able to gather some of this information and really understand how this thing's supposed to work in the first place. We use testing as our first step, because we kind of went through what Mike went through with this kind of sporadic caulking that worked and kind of didn't work. And then it was time to really get out there and do some testing. I think you might actually have a photo of us. Is that one of the slides, I think, of us up there doing the water testing? I'm not sure, but
no, I don't have it included in this slide deck, but I'll certainly find it.
The test that we did was a 1105 test where we build a chamber on the inside.
We do 1105. We do. We just don't have it specifically from this project. Sorry.
No problem. And that was really, that was our design test, right? And how this job shook out was, it was very important for us to identify and confirm the leak path and recreate the leak path. And boy, did we recreate the leak path. We're talking like 1.5 inches of water in this person's office, which they weren't happy about, but the client was happy because we actually recreated it under controlled conditions, right? And once that was recreated, recreate it, then we were able to really start to think about, okay, so now what do we do with this thing? We can make it leak. What's a solution for it? In this particular project, we threw some options at them, but no matter what, at the end of the day, when we kind of talk about the investigation part and the QA part of it, after the investigation, we did do a prototype, and that prototype was tested yet again, right? So if you think about testing in this particular case, we tested to make it leak. We did our prototype, recreated the same exact test on the prototype, didn't leak, that's good. But then we also had to sprinkle testing into the QA portion of it once we get moving to make sure that the quality of installation is being successful throughout the project. So testing had three purposes there. Find it, make sure you understand why it's happening, confirming your hypothesis and your solution, and then confirming that the contractor's installation is working properly as the job goes along. So testing is just woven in the, throughout this. And on a project like this, like Paul had mentioned, it's cool because you're out on the outside of buildings, you're building chambers on the inside, you're spraying water. It does really, I think it's exciting. Now, I do love the lab testing as well too, but it is fun to get out there and really do that. So when we're putting a design together on a job like this, so this 1105 is just one kind of test. There's other tests that we do. Your SRO, we used a dial pull test as a non-destructive way to ensure we're getting adhesion of your structural restoration overlay, right? So that's another test we wove into it. We used that test in the prototype, and then we used the test during QA as we went through the process.
I think it's great. A big part of the presentation that you gave, and Paul, I loved how Mark explains it, is he's extending the usefulness or useful life of these materials, right? So instead of feeling like you have to go back and take it all down, you are actually doing the testing that you need to say, okay, this is okay, it's just leaking air and water. And that's that key part of us working with folks like yourselves to be able to get us to that point, so then we can decide what that solution needs to be moving forward.
No, absolutely. And I think sometimes useful life, it's tough to extend some of these things, but I'll tell you what, I think what is always really helpful is showing them the alternative to that, right? So for University Towers is, okay, so it's going to cost you $4 million to replace your curtain wall, or $1 million to do an overlay, or whatever the numbers are. So you have to, I feel like a lot of times in our industry, people are looking for us for answers, and I feel like what we should be giving more often than not are options, and let them pick, right? There's not always one way to go, right? So I feel as a good consultant, my job is to give my client options, and then from there I give them my 2 cents, and then they pick. I shouldn't be picking it, and I shouldn't tell them what they want, right? They need to pick what they want based on good knowledge and education we pass along, and having some options if they're available, right?
Absolutely, and you mentioned it here with this spectrum restoration overlay solution, how it's going to go up and over that zipper gasket. That was the issue, sealing it on both sides with Spectrum 1, and now you've got it being back to being air and watertight. And
I like Mark, you used the word options, because that's the thing that I think we really try to do here is have all the options, right? Because the cliche is if you have a nail, right, or what is it? All you have is a nail or it's a hammer. Or
yeah, right.
It's the opposite, but but if you have all the options in front of you, then you're not limited in how you think about it and how you approach it, and you can lay that out for folks. So options are important.
But that approach, like we're saying, if you look at those boxes there, I mean, you really, to get a good project, you really have to do this. And I'll tell you, sometimes the most difficult thing we have, and you never would have thought engineering and consulting had so much sales in it, but it does, right? Because you got to sell the client to pay you to do the history, understanding these steps, right? They don't want to hear about that. They really don't. They don't want to pay for that. They just want to, unwrap something and it's done. And I think part of our industry's job is to be good at sales, right? How do we explain to them and sell to them that we need to be able to do this base information gathering so that they get a better solution? That's the toughest thing, I think, in our industry sometimes, is just to communicate and educate why this is necessary and have them buy into paying us to do it. And I think fundamentally, once they understand it and once they see any of us that are good consultants go through it, then they get it. But if they've never gone through that process before, man, I've seen pain in people's eyes. They just don't they don't, why am I paying for this? Why can't I just get a solution? So I think as an industry, it's always important to stand your ground and don't get in a situation where somebody wants you to provide a solution without them allowing you to do this, reconnaissance.
I'd love to do a future segment with you doing just that, going through that analysis of assuming where it was and then finding out where it really was in the end,
Yeah, Mark, do you sometimes share with the client then other case studies, I guess, or where you did diagnostics so they have a sense of the value that you'll bring? Or how do you persuade them to get on board with that?
Yeah, that's a great example. Definitely, I do bring in some projects and try to explain, some other case histories of other projects. University Towers is a great one to explain to them, that there's a lot of this legwork that has to be done to create a proper solution. So I think, you always talk about clients who maybe have been burned before by not going through the process. They're easy, right? Because they decided not to do it and they got burned for it. So I think the ones that have been burned are the difficult ones,
Yeah, exactly. Well, and I guess a big part of it, right, is being able to get the okay and then do some of this type of testing, right, so that you can show it. And I love this slide here. This is part of your presentation as well, where you go through just that lab, on-site, and then forensic. And I believe this is your colleague there doing that test that we're gonna have to feature one of these times too.
Yeah. So that's JP. He's like a gigantic testing nerd, big time nerd, almost as nerdy as Marcy, like very nerdy.
Well, I knew I liked it.
Very cool. JP is awesome. And we had these, 80 miles of structural restoration overlay. And we were kind of like, how do we make sure we're doing this right? I mean, I don't want to rip things off. I don't want to cut things. I don't want to do a typical pull test. What do I do? And I'm just sitting there thinking about it. And JP's hawking over my shoulder. He's like, well, I can. Next thing we have, here we have a test. So I think it's important. I know it's important that you use tests that are already pre-established. ASTM has a gazillion of them, which is great. But it's also, and what's a fun part of our job is being creative. How do we do this non-destructively? And this is what we came up with the SRO, which is Mike, who is our friend from High Rise, left behind these little dowels with a anchor on them. And as he put the SRO system, every so many, I forgot what we came up with, we told him to, use some sealant, stick it on there, and we'll do non-destructive pulls. We'll see what we get out of it. And if we're happy that we're consistently getting good adhesion of the sealant to glass, we got ourselves a good test. So that's a great example of, you got to think through the process of the repairs. And I think it's important as a consultant and an engineer to know where the potholes are in the construction process, because that's where you want to test, right? You want to test inside, outside corners. There's just good places to look for stuff. And it's not to catch contractors, not at all. I was a contractor. It's not to do that. It's just to confirm, are we doing the best we can? Is there a better way to do it? That's important too, right? So I think these tests really, to be creative with them and think outside the box of just ASTM is important. And then when do you do it is just as important. So a lot of these products, started with lab testing, and then a lot of the challenges are, how do we go from, controlled environment to hanging, 16 stories in the air and doing these things? And what does it mean? This particular test that we're showing you a photo of is, okay, now we're done. Now what, right? We're going to leave a wood dowel on the SRO. So it actually took a little bit of a QA process to have Mike have a straight edge, cuts it off, everybody goes home. You have to think through that whole entire process. In our jobs, I really like to do in place, in situ testing. I don't want to wreck it, right? I want to, because I've already been through my due diligence in my investigation of my prototype. So now I want to have a test that I'm not breaking or taking apart or, doing something invasive. I want to have a good test that gives me a good result,
Another future segment, we're gonna have JP show us how he did that. I have one with a fish scale too that I do. So maybe it'll be JP and I nerding out on our testing.
It's awesome, man. We have that little lab that we're building slowly but surely down in Bund, and I've already seen stuff in that lab. I'm like, what is that? Like, where did he come up with that from? So that's the creativity that I think we all enjoy having at our jobs every day, which a lot of people, I don't think, unfortunately do, which is cool. Here's some more water testing. This is for a project that had an existing coating on it. The building still leaked, even though they had a coating on it. We had worked with a pretty high profile manufacturer to understand what was going on. And JP called this one a hurricane in a box, which is basically a backwards 1105, where we put the pressurization and the water all within the chamber and basically try to recreate the leaks. And this test proved that the coating itself had fundamental flaws in it, not the coating material itself, but the application technique. It had some pinholes, it had some issues with bond between mortar and the block. We were able to just kind of prove that. And we did this to, again, recreate the leak, but then through a prototype, we applied a different coating system over top of it. We did adhesion testing to make sure we got a good adhesion. Then we finally put a hurricane on a box on the wall, tried to make it leak again, didn't leak. We got ourselves a solution, right? So this was instrumental. This testing procedure was instrumental not only in the diagnostics, but actually helping support the owner who, in this case, wasn't real happy with his previous contractor who coated the building. You know, to me, a lot of times it's not whether I agree or disagree. The test is going to tell us what's up, right? And this is a great example of, yeah, and this is, you know, a great example of, I'm telling you, the both of you, all of us, you would walk up to this wall and you would be like, huh, man, I don't know why it's leaking. Really, you couldn't really see. It wasn't jumping out at you with these giant pinholes, right? So you needed the pressure. That's what you needed, and that's what no one used before. Everybody else used just a 502 nozzle, just a water nozzle, which didn't give you what you needed. You needed the pressure, and the pressure was really what created it here.
I always just find it so much easier. You can theorize with somebody, but if you can't show them, you know, it's hard to believe, right?
Well, and that's what you've taught me, Marcy. Agree, disagree, who cares? Let's run the test.
Yeah, let's take a look at it.
Let's see what.
Let's just, yeah.
That's a great way to put it, Paul. I swear, a lot of times I feel like I'm saying that a lot. It's like, it does. Why are we all standing here thinking about what it might be? Just put it on the wall and make it happen, right? This, coincidentally, this is a great example. So this is a nice historic high-rise in Baltimore that their study that came up, their reserve study came out, and they said, hey, by the way, your windows are 50 years old. You have to replace the windows. And the condo board, who is very bright, a lot of architects and engineers on the board, which are good and bad sometimes, you never know. But these cats were pretty smart, and they said, well, prove it to me. Why do I have to replace these 50-year-old windows by this famous architect? Why? Just because your reserve study says so? How about the windows? Shouldn't we check to see if the windows really need to be replaced? Again, reached out to our lab, and they were able to come up and do air testing and water testing. This is a 783 test for air to test the old historic windows to see how are they performing. Do they need to be replaced? Don't they need to replace? Why are we replacing something if it really doesn't need to be? And this was an in-field test for air and water that helped us identify that actually maybe they're not as good as a brand new window, but they're performing just fine. There's really no reason to do it. They probably need to start looking at replacing these windows in 5 years or so. This is not today. But without doing this testing, there's nothing substantial to prove that they needed to, other than some guy who wrote a report and said your building's 50 years old, you need to replace your windows. So testing can be used in a lot of ways to confirm that things really need to be done in the first place. How are they performing in the first place? And the one thing that this test did point out was that they had to replace the bulb in the operable window, the bulb gasket. Once we replaced that, these things passed the air test of a contemporary test for a contemporary window right now. It actually passed. It was just the bulb gasket. That was it. So it was like a $75 piece of material that you put in, and all of a sudden they passed the air test.
That's great. That's great. I mean, I go back to my plumbing problem. I mean, I normally you'd run out and buy a new toilet. My toilet's like been in this house forever. It was just the mechanism heading to the toilet that needed to be repaired. So, so we did air, we did water. Here's some more testing that you featured, forensic water testing.
Yeah, I enjoy this. You know, we do have a lot of work right now, and my guys are running around a lot helping Whiting Turner and some of these other guys in new construction, right? Doing new construction testing, which isn't necessarily forensic. That's just proof testing that things are being installed properly, what may be done. And I think it's interesting because our lab kind of does both, right? They do these new construction testing. We also do forensic testing, but it's a different vibe. You know, out in the field on a new construction site, it's pass, fail. That's it, right? It either passed or it failed. Forensic is just the opposite. You're trying all kinds of things, try and recreate a leak. And you know, the one down there, the sill dam test, which is ridiculously simple to do. Fill up the sill with water and see if it leaks. Seriously? No, that's seriously a test that somebody ASTM probably took 9 years to develop it, right? But you're pouring water at a sill.
As long. That's what I'm always like, someone needs to do, you know, the test methods for dummies book where it just tells you what you need to know.
Yeah. So this is a great test. This is also a great forensic test. And where we see it, and why I mentioned new and forensics is we encourage our contractors that we're working with in new construction to do the sill dam test on new windows. Why wouldn't you do that? Take them off the truck, do a sill dam test. If they pass, move on. If they don't, you better go talk to your window guy. So there's just a lot of love between, you know, existing structures forensics and new construction. You really got to connect the dots, because over the years they've kind of been separate worlds. You had the new construction testing folks, and you had the forensic people who did it. So we bring them together, and I think a lot of times we learn how to be better designers from our forensic testing, right? Because you're taking things apart that weren't done correctly. So when you're looking at a set of drawings, in my brain, I'm going, oh, yep, I remember this. I saw that didn't work. Let me redline this so we can talk about maybe how to do that differently. Because if we do it that way, it's going to wind up like that job, you know? So I think there's a lot to share between forensic testing out in the field and new construction testing. And the sill dam test is a great idea. The 2128, ASTM 2128, by hands down, one of my favorite documents in the whole world. If anybody doesn't have it on the call, go get it. It's a great document. It walks you through all these processes and procedures for water testing and identifies a lot of these tests that are out there in the ASTM and the AMA standards for it. But forensic testing is, you have to be careful. I've already seen people use fire hoses to do forensic testing. I've seen people jam water into, you know, water hose into a corner and say it leaks. There can be a lot of false positives if you don't really have a handle on how to do this, right? So I try to have a good conversation with a lot of my contractor friends who do some of this stuff as good, smart contractors, and just make sure that they know what they're getting themselves into, and make sure they're not going down a path of creating a false positive, repairing something, and then somebody not being happy because you spent $10,000, $20,000, $30,000 and it didn't really resolve the problem. So we try to coach up our contractor friends as much as possible to do what they need to do to take care of their clients. But I try to give them a bridge that, you know, if you get to a certain point and you're just not comfortable with it, come see me, we'll come out, we'll help you out. Let's make sure that we're going down the right path. And if that's all I need to help you with and I'm gone, I'm cool with that too. So I think it's just trying to get contractors comfortable that consulting companies like ours and others out there that do all this stuff, we're here just to make sure the industry has a better direction and we don't give false positives and maybe do tests that don't really solve problems. So we always try to work with our contractors to fit what we need to fit them, and if we need to get out of the hair, we will. If they want us to roll into it and then help them do it as a bigger project, we're happy to do that too. But bringing that knowledge of these different tests to them is what's important, so that they know they have these tools they can use when they do water testing.
I'm just thinking of so many ideas. I'm going to do a whole segment on ASTM 2128, right? I think that would make a lot of sense. Well, we're kind of creeping in on the time frame here. I know you also talked about thermal testing, right? There's a lot that can be done by doing thermal testing, as well as the infrared with the blower door testing. So those are just two more things. Maybe we'll have you back on where you can talk more about all of that. But this has been great. A lot of what we talked about today came from a presentation that Mark has given. It's called the Foundations of Fenestrations. It was part of our 6 sides of your structure. So I have it recorded, and I know that if you reached out to Mark, he could provide it as well. But it's a great presentation, lots of tips and tricks. I love how you go through the whole process of looking at new construction, and then also obviously restoration and a forensic side. So it's really helpful. But I'm, Mark, so appreciative that you came back on with us today. Thanks for being able to participate with us. And I know we're going to get together soon.
That's right. Thank you all. I appreciate it. Have a good weekend.
Thanks, Mark.
Thanks, Mark.
That was fantastic. He's creeping up on Pat Garrity.
He is. That's right. Pat Garrity was our #1 a guest contributor for a while there, and I think Mark Sinton up there, Leonard James too, out of Boston. So we're definitely appreciative of all of our contributors. And as always, if you have a case study, a topic, or something of interest that you want to be able to share with us on Tremco Live, we would love to be a part of it. Right now, we're getting ready. We're starting to gear up for the month of July. We've got one more Friday in June where we're going to do a debate on nail sealability with Keith Nelson and Keith Simon. The Battle of the Keiths, talking about nail sealability, and then we're going to pop into July and be on the road with Tremco.
Nice. Nice.
So we're going to get to some job sites and get some great footage of you guys in action.
Well, Marcy, it's a great half hour.
Yeah, it was a great half hour. So that's a wrap, right?
Yep, we're gonna put our feet up, maybe get a drink.
It's time. Yeah, it's that time. So thanks everybody. Enjoy your weekend, and we'll see you next Friday.
Take care, be safe.